So my name is Abhishek Asthana. I'm a senior lecturer at Sheffield Hallam University. I also represent University Alliance, which is an alliance of 20 universities in England and Wales. And we've started a doctoral training program in energy for the PhD students. So this presentation is about developing innovative acoustic. These pipelines have to be properly insulated because crude oil, it's so viscous that it has to be transported at 120 degrees Celsius. If it cools down, there's loss of heat, then what will happen? It'll make wax. It'll choke the pipelines and finally block them, or your pumping costs will increase exponentially. The second application is for liquefied natural gas, and natural gas is liquefied at minus 162 degrees Celsius. It's actually transported at minus 170. It's a cryogenic application. Now, if there's heat leakage into your pipeline, then what will happen? It'll start boiling. Once it starts boiling, its specific volume increases and it can cause explosions. So both have to be insulated, and it's safety requirements. It's also an energy efficiency requirement, plus costs. So the costs of just cladding these pipelines is up to $120 per hour in parts of US and Canada and Australia and so on. So I'll just show, So in a traditional pipeline, you have the inner pipe, which is maybe steel, and then you've got to cover it with a layer of epoxy so that it doesn't corrode. Then you put your insulation so that the heat doesn't go in or out. Then you put a moisture barrier so that moisture can't go in, and then finally the metal jacket and another coating on the surface. So it's a very tedious and expensive process, and if your costs are $120 per hour, it can be very, very expensive. So we need to insulate it thermally, but we also need to insulate it against vibration and noise, so acoustic insulation, because pipelines have compressors and pumps and so on associated with it. The vibrations and noise can cause leakages, and it could be explosive. Then also it's disturbing to the environment and community and so on. And there's also very strict legislation in many parts of the world about noise insulation. So we have to have both thermal insulation and noise insulation on pipeline. So we've developed a new coating. So to keep the noise out, what's being done in the industry today is the use of lead and bitumen, which are not very good materials. Lead is carcinogenic. So we've developed this mass-loaded vinyl, which is basically PVC with barium minerals impregnated into it. So it's a high-density absorber, very good at stopping noise, and another good benefit is it's self-extinguishing, so it won't catch fire even if there is fire. It satisfies the industry standard requirements and gives a mean reduction of 26 decibels. So very good performance. It doesn't contain bitumen or lead. It's recyclable and so on. I'll skip some of the technical details, summarize the results later. So what we've done, we've gone one step beyond that, getting rid of lead, getting rid of bitumen, but bonding MLV to metal so that a two-stage process can be reduced to one stage. Okay, so we stick the MLV to a metal sheet, and it's a one-step process. So the people who are working on these pipelines, they just have to do one step, not two steps. It's not easy to do it. We tried various ways, melting it to stick it to the surface. We tried different kinds of sprays, glues. Finally, we came up with the right solution. So I've got a very short video with you, a few seconds, which will give you a good picture of how this is done, and then I'll conclude. So this video shows how pipelines are assembled. They're being transported by a ship, and you see the two pipelines are being joined, and then they will align it properly, and then they will weld it so that there's a good seal. So I'm just fast forwarding it so you can see the welding taking place. And after the welding, what they have to do is ensure that there are no sharp, cuts or things like that, which will tear the insulation. And yeah, so this is the stage of coating. So now they've made it smooth, and now they're going to put this epoxy sheet. So you can see 2 workers are required, and per meter square there's a significant cost to it. So they'll seal it with fire so that it melts and there's no possibility of moisture going inside. And after this they will put the insulation and continue with the metal cladding and so on. So I'll stop it here, come back to my presentation. So what we've done is we've eliminated the inner layer. You don't need to put epoxy. You don't need to put a separate sheet inside to keep the moisture out. You just need to put, after insulation, this mass-loaded vinyl with the metal jacket bonded together. So significantly reduces labor time and costs. So these are the standard tests which we conducted. You can see the picture inside the pipeline and damping. So it's good for stopping heat. It's good for preventing corrosion. It stops noise and vibrations as well. And you can see it's as good as lead or even better in many conditions at stopping your noise. So stops noise, the no carcinogenic materials, it's recyclable, and the no environmental or health impacts. Finally, this is my last slide. It gives enhanced acoustic damping. There's no slipping because there's just one layer, so it's much easier, much more compact. There's no gaps in between. The moisture barrier is on the underside, so it's also protected. You don't need to. And you can see the savings. This is the real benefit, the economic benefit. In the standard jacketing system, if you need 1 meter square of pipeline covered, you need an average of 1.3 man-hours. Remember, the hourly rate is $120 per hour. In our new system, it's dropping to 1.1 hours, which is a 15% saving, and that's significant. And there's very good addition, and we've applied 2 patents on this product. Thank you for your kind attention. I'll answer any questions.